This is a straw. Let's put a magnet through it. Now, let's drop another magnet on it. Look, it floats. Is this magic? Nope, it's science. The properties of magnets are such that you can have fun with them. Magnets have three basic properties: attraction, repulsion, and direction. Let's learn about the first property: attraction. Magnets attract iron. Let's drop these paper clips, which are made of iron, into the glass of water. Do you think you can remove the paper clips without putting your hands into the water? Watch. The magnet attracted a trail of paper clips which came out of the glass. Do magnets attract non-metals too? Let's find out. Let's take this sand and add iron filings to it. Now we have a mixture of iron and sand. Let's move this magnet over the sand to see what happens. Notice how the iron filings jump out towards the magnet. The sand stays where it is and does not move towards the magnet. Now, place the magnet with the iron filings over another surface and remove the iron like this. The iron is separated from the sand. This illustrates that magnets don't attract non-magnetic materials like sand. What about this 1 rupee coin made of stainless steel, which contains iron, and this old coin made of aluminium? Do you think the magnet will attract the coins? Let's see. The magnet attracted the 1 rupee coin because it contains iron, which is magnetic. But the old coin made of aluminium was not attracted to the magnet. This proves that not all metals are attracted to magnet. Some metals, like aluminium, are non-magnetic. Magnets with similar poles repel each other. What is the meaning of similar poles? To see this property, we need to use bar magnets. Bar magnets have north and south poles at both ends. Opposite poles of the magnets attract each other. While similar poles repel each other. You can make use of the repelling property of a magnet to push your toy cars. On the red car, stick a bar magnet with the north pole facing the front and the south pole facing the back. On the blue car, stick a bar magnet with the south pole in the front and the north pole at the back. Now, let's move the blue car towards the red. Look, the red car moves. This is because the magnets with similar poles repel each other. The floating magnet you saw in the beginning behaved that way because it was placed over a magnet with a similar pole. That is why the magnets repelled each other. Next, let's learn about the third property of magnets: direction. A magnet functions as a compass. A compass is an instrument which always points to the north. Thus, it is used to determine direction. This means that if we string a magnet in the air so that it can move freely, it will always come to rest in the north-south direction like this. Interesting, isn't it? Would you like to make your own compass? All you need is a needle, a piece of cork or thermocol piece, and a glass of water. First, let's magnetize the needle. Magnetizing iron means treating it such that it faces the north-south direction like a magnet. Here, we rub a magnet on a needle 20 to 30 times, facing the pointy side away, so that the needle starts functioning like a magnet. Remember that the pointy tip is your north pole, and the thicker end of the needle is the south pole. Once the needle magnet is ready, stick it through a cork piece or thermocol piece if you don't have cork, and float it on water. The needle will point in the north-south direction. Your compass is ready. A compass is especially useful in finding directions outdoors. However, you should be careful to ensure that its magnetism is not lost. To make sure your bar magnets don't lose their magnetism, avoid keeping similar poles together, because similar poles repel each other and thus weaken magnetism. Instead, store your magnets with opposite poles on the same side. Use materials that magnets don't attract, like wood or plastic, to separate the magnets so as to not upset the magnetism. And use soft iron at the ends to neutralize the poles of the magnets. In addition to badly storing magnets, heating, hammering, or dropping a magnet can also make magnets lose their magnetism. Now you know that magnets attract iron. Magnets don't attract non-metals like sand. Magnets don't attract all metals, for example, aluminium. Magnets with opposite poles attract, while magnets with similar poles repel each other. Magnets, if left free, always face the north-south direction. If a magnet is rubbed on a piece of iron, the iron starts facing the north-south direction like a magnet. Magnets, if not stored properly, heated, hammered or dropped, can lose their magnetism.